Hey kids, welcome to section 8.4, Z-test for a proportion. Today we're going to learn how to do hypothesis tests for proportions using the Z-test. So many hypothesis testing situations involve proportions. A hypothesis test involving a population proportion can be considered as a binomial experiment when there are only two outcomes, and the probability of a success does not change from trial to trial. So we've got three assumptions this time for testing a proportion. One, the sample must be a random sample. Two, the conditions for a binomial experiment are satisfied. That's when we have two outcomes. A probability of success is consistent. We have a fixed number of trials, and it is a simple random sample. The third condition is that your successes must be greater than or equal to 5, and your failures must be greater than or equal to 5 as well. We have a test statistic formula for the proportion. We have z equals p hat minus p over the square root of pq over n. Notice that we are using p and q, and if you don't remember, q is equal to 1 minus p. Also, we are using z now, so we will be inverse norming our test or our critical values. No degree of freedom here, so your sample size is what we're going to use. We've got our same 5 steps for the hypothesis test listed. So now we're going to be dealing with proportions, or otherwise known as percents. So we're going to talk about how 10% of the population does this, or 20% does that, or some other activity. So let's jump right into obese young people. A researcher claims that based on the information obtained from the Centers for Disease Control and Prevention, 17% of young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 people ages 2 to 19 and found that 42 were obese. Add alpha equals 0.05. Is there enough evidence to reject the claim? So in these problems, we're going to need a p hat, we're going to need a p, we're going to need a q, and we're going to need an n. So our p hat is our sample proportion, and it looks like we sampled 200 people. That's our n. And out of those 200 people, we found 42 were obese. So our p hat is 42 over 200. If I simplify that, I get 0.21. Our P is our population proportion. That is our 17%. So we're going to write that as a decimal, 0.17. Our Q goes with our P, not our P hat, but our P. And so our Q is 1 minus 0.17 or 0.83. Now we can do our hypotheses. Our null hypothesis goes with our P. So P is equal to 0.17. That is our claim. Our alternative hypothesis, it doesn't say greater than or less than, so we're going to assume not equal to 0.17. We can draw our graph. It's not equal to, so we're shading a little bit on both sides. Our alpha being 0.05, we need to divide by 2, so 0.025. This is a z-test, so we are going to have a critical value of z equals. We're also going to do plus or minus because we have a critical value on each side. To find the critical value, we're going to inverse norm 0.025. So that's going to give us critical values of plus or minus 1.96. Okay, so now we're going to do our test statistic. Z equals p hat minus p over the square root of pq over n. So that's going to be 0.21 minus 0.17 divided by the square root of 0.17 times 0.83 divided by 200. Now this is a z value, so it's going to have 2 decimals. If I type this into my calculator, I'm going to get 1.51. So now we need to make a decision. Our cutoff is 1.96, but we're at 1.51, so we are not in the critical region, so we do not reject the null. So since 1.51 is not in the critical region, we do not reject the null. Okay, so our null is our claim. We're not rejecting the null, so there is not enough evidence to reject the claim. There is not enough evidence to reject the claim that, and our claim was that the proportion was equal to 17. Claim that the proportion is equal to 17%. So the question, is there enough evidence to reject the claim? The answer is no, there is not enough evidence to reject the claim. All right, so let's take a look at the next one. Female gun owners. All right, so the Gallup Crime Survey stated that 23% of gun owners are women. A researcher believes that in the area where he lives, the percentage is less than 23%. He randomly selects a sample of 100 gun owners and finds that 11% of the gun owners are women. Add alpha equals 0.01 is the percentage of female gun owners in his area less than 23%. All right, so we need a p hat, we need a p, we need a q, and we need an n. Okay, so our sample size is 100. Our p hat is going to be 11%, so 0.11. Our p is our population proportion, that's the 23%, so 0.23. And our q is 1 minus 0.23, or 0.77. All right, our hypotheses, our null hypothesis is going to be p equals 0.23. Our alternative hypothesis is that it's less than 23%, and that is our claim. So when we draw and shade our picture, we're going to shade on the left. We're going to grab all of the alpha, 0.01. Our critical value is going to be negative because it's on the left. If we inverse norm 0.01, we're going to get a critical value of negative 2.33. So now let's look at our test statistic to see where our data falls. We have p hat minus p over the square root of pq over n. So that's going to give us 0.11 minus 0.23 divided by the square root of 0.23 times 0.77 over 100. This is a z test statistic, so it gets 2 decimals. Type it in my calculator, I get negative 2.85. So now we take a look at our picture. Our critical value is negative 2.33. Our test statistic is negative 2.85, which puts us in the critical region, which means we're going to reject the null. So since negative 2.85 is in the critical region, we reject the null. Okay, so our claim was the alternative. We are rejecting the null, so there is enough evidence to support the claim. There is enough evidence to support the claim that, and our claim was that the percentage is less than 23%, that the proportion is less than 23%. The question is the percentage of female gun owners in this area less than 23%? And the answer is yes. Okay. Next, we have replacing $1 bills with $1 coins. A statistician read that less than 77% of the population oppose replacing $1 bills with $1 coins. To see if this claim is valid, the statistician selected a random sample of 80 people and found that 55 were opposed to replacing the $1 bills. At alpha equals 0.01, test the claim that less than 77% of the population are opposed to the change. All right, so we've got a p hat, we've got a p, we've got a q, and we have an n. So our sample size is 80, and out of this 80, 55 were opposed. So that's our p hat, 55 over 80. Now, when I divide this, I'm going to get more than 3 decimals. So I want to round to 3 decimals because proportions always have 3 decimals. Anytime we did proportion or probability or anything with p, we had 3 decimals. Our population proportion p is 0.77, which means my q is 1 minus 0.77, which is 0.23. Okay, now I'm ready to write my hypotheses. So my null hypothesis is going to be p equals 0.77. My alternative hypothesis is that it's less than 77%, so p is less than 0.77. This is also our claim. We're going to draw a picture. We are shading to the left because we are less than. We grab our entire alpha 0.01. Then I find my critical value. It's going to be negative because it's on the left. And I'm going to inverse norm 0.01. I'm going to get negative 2.33. Then I need to calculate my test statistics. So z equals p hat minus p over the square root of pq over n. So that's going to give me 0.689 minus 0.77 over the square root of 0.77 times 0.23 over 80. This is a z value, so it's 2 decimals. I get a test statistic of negative 1.72. So if we look at our critical value, the cutoff is negative 2.33. Our test statistic is negative 1.72, which means we are not in the critical region, so we do not reject the null. So since negative 1.72 is not in the critical region, we do not reject the null. Okay, so we are not rejecting the null. Our claim is the alternative, so therefore we do not have enough evidence to support the claim. There is not enough evidence to support the claim that Support the claim that the proportion is less than 77%. That the proportion is less than 77%. So then we answer the question. There is no questions. We don't have to answer it. Okay, one more. An attorney claims that more than 25% of all lawyers advertise. I guess that's more than. A random sample of 200 lawyers in a certain city showed that 63 had used some form of advertising. At alpha equals 0.05, is there enough evidence to support the attorney's claim? Okay, so let's see. We need a p hat, we need a p, we need a q, and we need an n. Well, our sample is 200, and of those 200, 63 had used some form. So our p hat is 63 over 200. Divide that, you get 0.315. Our population proportion P is 25%, so 0.25, which leaves my Q 1 minus 0.25 or 0.75. Now we get our hypotheses, the null and alternative. Our null hypothesis, P equals 0.25. Our alternative hypothesis is more than 25%. So P is greater than 0.25, and this is also the claim. If we draw our picture, we're shading on the right because it's greater than. Grab our entire alpha, which is 0.05. Our critical value is going to be positive because it's on the right. And if we inverse norm, we get 1.64. All right, so now we need to do our test statistic. Z equals P hat minus P over the square root PQ over N. So that's 0.315 minus 0.25 over the square root of 0.25 times 0.75 over 200. This is a Z value, so it's 2 decimals. Type all that in, round to 2 decimals, you get 2.12. Okay, let's compare. You've got a critical value of 1.64, a test statistic of 2.12. That means we're in the critical region, which means we reject the null. So since 2.12 is in the critical region, we reject the null. So since we're rejecting the null and our claim is the alternative, there is enough evidence to support the claim. There is enough evidence to support the claim that, and our claim is that more than 25%, that the proportion is greater than 25%. So answer the question, is there enough evidence to support the claim? And the answer is yes. All right, kids, I'm going to be done here. So if you have any questions, please let me know. And as always, keep calm and keep trucking.